In our last class, we talked about vertical asymptotes, and in this class, we are going to be taking more complex problems on vertical asymptotes. If this is your first time of seeing my video, consider subscribing, follow my page, like and share this video to your friends. Also, we have f of x will be equal to x minus 1 all divided by x squared plus 5x plus 6. And on this side, we'll have f of x to be equal to x squared plus 3x minus 10, all divided by x squared minus 4. So we were asked to obtain the vertical asymptotes of these functions. Right. And we know from our last class that when we are asked to obtain vertical asymptotes of any rational function of this type, we first of all check if we can actually factor the function that we have, and if we can actually factor anything in the function, both on the numerator and the denominator, then we should factor as far as possible and cancel out common terms, common factors, and then set the denominator equal to 0 or set the bottom equal to 0. And in this case, we have x squared plus 5x plus 6. We actually can see that we can factorize this quadratic expression down the denominator right here, right? And if we factor this denominator, we have x minus 1 to be equal to x plus 2, x plus 3. So these are the factors of this function, right? Of this quadratic expression. And so we have seen that, we have taken the first step to factor out to factorize the function both on the numerator and the denominator, right? And now we'll check if there is actually any common factor we can cancel. Both, we can cancel on the numerator and also cancel on the denominator. But in this case, we have seen that we cannot actually, we don't have any common factor right here. So what we do is to set the denominator equal to 0, right? So if we set the denominator equal to 0, we'll have x plus 2, x plus 3 will be equal to 0. So if we separate these factors, we'll have x plus 2 will be equal to 0 and x plus 3 will be equal to 0. So subtract 2 from both sides, we'll have that x will be equal to negative 2 and x will be equal to negative 3. Right. So this is the vertical asymptote of this function. Vertical asymptote of this function is x, minus 2 and then minus 3. Right. So we are going to show a graphical representation of what this actually looks like. So we have this graph right here, and we have the dotted invisible horizontal line, which we call the horizontal asymptotes, right? And we have here to be negative 1, negative 2, negative 3, negative 4 to infinity. And remember that our vertical asymptotes are minus 2 and minus 3, right? So we are going to take a vertical dotted line that will correspond to negative 2 and negative 3, right? So have all the way down to infinity, all the way down to infinity, right? So the vertical lines correspond to the to the asymptotes. And these are, they are points where the function is not defined for x. So if we take our graph, we'll notice that our graph will move upward just close to this dotted line, but we never cut across the dotted line, right? And the same thing happens here from to negative infinity, but we never cut across these dotted lines, right? And also the same idea happens here again, and it will never cut across the negative line, because I mean the dotted lines, the invisible lines, which are the asymptotes, and they are points where the function is not defined for x. So this is exactly the graphical representation of what this means. We have the vertical asymptotes to be -2 and -3. And in the next function, we have x squared plus 3x minus 10, all divided by x squared minus 4. Right. So in this function, if we take a good look at, what we'll have right here, we'll see that we can actually factorize both the numerator and the denominator. We can factorize the denominator using difference of two squares, since 4 is a perfect square, and we'll have x squared as well. So if we factorize what we'll have at the numerator, we have x plus 5. And we have x minus 2. And then all divided by the difference of 2 square, we have x minus 2 and x plus 2. Yeah, we use the law of difference of two squares to factor out x squared minus 4. And if we multiply these two factors, we obtain x squared minus 4 again. So now we are going to, this is where the second rule comes into play right now. You see, we have factored out, we have factorized both the numerator and the denominator, and then we have common terms here, right? We have x minus 2 at the numerator, and also x minus 2 at the denominator. So we need to cancel out common terms, common factors. So we cancel this, right? And we are going to set the denominator, we'll set the bottom equal to 0. So what we have left is x plus 5 all over x plus 2. So now let's set the denominator, the bottom, equal to 0 to obtain the vertical asymptote of this function. So we'll have x plus 2 will be equal to 0. And if we subtract 2 from both sides, we have x to be equal to -2. So good. The vertical asymptote of this function is actually -2. And if we want to represent this in a graphical representation of what we have right here, we have something like this: -1, -2, and so on to infinity. And do not forget to represent your horizontal asymptote, but that will be in our next class. We'll be talking about horizontal asymptotes in our next class. And the vertical asymptote should correspond to, our invisible dotted line should correspond to the vertical asymptotes. These invisible dotted lines are the points where the function is not defined for x, right? So our graph will go this way, right, to -infinity, without cutting across this line. It will almost touch the line, the point, the dotted lines, but it will never cut across. It will never touch the line, right? So this is actually the representation of what we have here as the vertical asymptotes of this function. But what you need to have in mind is you must always remember this rule to first of all factor out what you have, any function you have. Check if you can actually factorize both numerator and denominator, right? So after factorizing what your function, you check if there are common factors that you need to cancel out. So when you are done canceling out, set your denominator or the bottom equal to 0 and make x the subject of the formula, and you will definitely obtain your vertical asymptote of your function. So thank you very much for watching. Hope to see you on our next class. Make sure you subscribe, share this video to your friends, and help this channel grow. See you on our next class. Bye for now.